You can't. Right. You can't break 79. So that means the rest can do. So wonderful. I only have so few hands. Can I assume all cannot do, but you all didn't raise your hand? Chey. Okay. Now, what is the first observation here? Can I have a few observation? Now, you need to know the thinking process before you can do. Uh, First question you always ask yourself is, can you do what? Dexter? Split the x plus 2. Very good. But before you split the x plus 2, you got to ask yourself the first question. And the first question is this. I put it in red. Like that, like that, like that, like that. Right? Same base. Because if can same base, the question is very simple. Agree? Can it be same base? No. No. If no, then what must we do? I want to use substitution, right? But do you realize that I also cannot use substitution? Why is it I cannot use substitution? It's really different base, as in 2x and then 5x, right? Right? So if I can use substitution means okay. So let's go through the thinking process again. Can I use substitution? The answer is yes if you have 2x then 2x, right? Something like that, right? Something like that, I can use substitution, right? But this case cannot because I got 2, I got 5. So what must come to your mind? You must come to this consensus. You must ask yourself, hey, what happened if I have 2 to the power of x times 5 to the power of x? Can I pause for 5 seconds and you write on your paper what is the answer of this? Write this down. A m times b m, sorry, yes, equals to ab power m. And that is why the answer is 10 to the power x. Can follow? Can follow? Then what Dexter say will come true. This is 2, this is 5. I hope I want to combine these two together. But before I do that, I got to split the x plus 2. So Dexter mentioned something about splitting. 2x times 5. What happened? 5. How do I split the x plus 2? Very good. And what Kun say is true as well. I cannot split the 79 into something base, right? Someone mentioned something. You, right? Jia Yan. So 2x times 5x is 10 to the power x. What do I do next? Do I want the x to come down? I want x to come down. I don't want. Because x come down means x become the base. When x become the base, it's easier to solve. Right? So maybe I write in red. I want the x to become the base, and one of the method is to add log on both sides. Do you still remember this trick? So can I demonstrate to you this trick? So I add log on both sides. So what do I write? Log. So I literally just add the log on both sides. Now I add the log on both sides. Question, can my x come down? So quiet. Can my x come down? Answer is no. What's the reason? I have 1, I have 2. Right? I have 2 things there, right? So my x cannot come down. So what can I do? Can I split them? So let's recap. What is log PQ? Log P plus log Q. Still remember? So if I have this, what can I write next? Log 10x plus log 5 squared equals to log 79. You notice I never do anything to the 79 or 5 square because they are just numbers. So boring. Oh, why? I don't know. But what can I do here? I don't know yet. I don't know yet. What can I do here? Log 10x. What can I do here? The x can come down. And what is log 10? Log 10 is 1, right? Because that is log base 10, 10. Log 10, 10 is 1. So this is x. And definitely I don't want the log 5 square to be there. So I just subtract. Oh, watch anime yesterday. Oh, look so tired. Huh? For training, I see, I see. Hockey? Netball? Badminton. Okay. So like that, okay? Okay. Press calculator and what's the answer? 0.500. I don't know. Do you get it? Oh, let's see. Now what Tiffany did over here is 10 to the power of x times 5 squared. Agree 5 squared is a number? Yes, huh? So what she did was she divide the 5 square over. So 5 square is 25. I have a number like that. After that, what do? I add log both sides. And then x will come down. Log 10, 10 is 1. This one is just a calculator game. Right? And then I get 0.500. Is it easier? Okay. I pause it so that you may want to